Chapter 2, Units of Measurement. Chemistry and measurements are an important part of our everyday lives. Levels of toxic materials in the soil, air, soil, and water are discussed in our newspapers. We read about radon gas in our homes, holes in the ozone layer, trans fatty acids, and climate change. Understanding chemistry and measurement helps us to make proper choices about our world. Think about your day. You probably took some measurements. Perhaps you checked your weight by stepping on the bathroom scale. If you made some rice for dinner, you added 2 cups of water to 1 cup of rice. If you didn't feel well, you may have taken your temperature. Whenever you take a measurement, you are using a measuring device such as a balance, a measuring cup, or a thermometer. Over the years, you have learned to read markings on each device to take correct measurements. Scientists measure the amounts of materials that make up everything in our universe. An engineer determines the amount of metal in an alloy or in the volume of seawater flowing through a desalination plant. A physician orders laboratory tests to measure substances in the blood, such as glucose or cholesterol. An environmental chemist measures the levels of pollutants, such as lead and carbon monoxide in our soil and atmosphere. By learning about measurement, you'll develop skills for solving problems and how to work with numbers in chemistry. An understanding of measurement is essential to evaluate our health and surroundings. Section 2.1, Units of Measurement. Suppose you walk 1.3 miles to campus today carrying a backpack that weighs 26 pounds. The temperature was 72 degrees Fahrenheit. Perhaps you weigh 128 pounds and your height is 65 inches. These measurements of units may seem familiar because they are stated in the U.S. system of measurement. However, in chemistry, we use the metric system in making our measurements. Using the metric system, you walked 2.1 kilometers to campus carrying your backpack with a mass of 12 kilograms when the temperature was 22 degrees Celsius. You have a mass of 58.2 kilograms and a height of 165 centimeters. Scientists throughout the world use the metric system of measurement. The International System of Units, SI, or System International, is the official system of measurement throughout the world, except for the United States. In chemistry, we use metric and SI units for length, volume, mass, temperature, and time. Length. The metric and SI unit of length is the meter. A meter is 39.37 inches, which makes it slightly longer than a yard. The centimeter is a smaller unit of length. It's commonly used in chemistry and it's about equal to the width of your little finger. For comparison, there are 2.54 centimeters in 1 inch. Such useful relationships between different units of lengths follow. Volume. Volume is the amount of space a substance occupies. The SI unit of volume, the cubic meter, is the volume of a cube that has sides of the measure 1 meter in length. In the laboratory in the hospital, the cubic meter is too large for practical use. Instead, chemists work with metric units of a volume that are smaller and more convenient, such as the liter, the milliliter. The volume of 1 milliliter is the same as 1 cubic centimeter. A liter is slightly larger than a quart and contains 1,000 milliliters, as shown in Figure 2.2. A cubic meter has the same volume of 1,000 liters. Some useful relationships between different units for volume follow. Mass. The mass of an object is the measure of the quantity of material it contains. The SI unit of mass, the kilogram, is used for larger masses such as body mass. The standard for mass, the International Prototype Kilogram, is a cylinder that's made of platinum of radium alloy. In the metric system, the unit of mass is the gram, which is used for smaller masses. There are 1,000 grams in 1 kilogram. In comparison to the U.S. system, the mass of 1 kilogram is equivalent to 2.205 pounds, and 453.6 grams is equal to 1 pound. Some useful relationships between different units for mass follow. You may be more familiar with the term weight than the word mass. Weight is the measure of gravitational pull on an object. On Earth, an astronaut with a mass of 75 kilograms has a weight of 165 pounds. On the moon, where the gravitational pull is 1/6 of the Earth, the astronaut would weigh 27.5 pounds. However, the mass of the astronaut, 75 kilograms, is the same on the moon as the Earth. Scientists measure mass rather than weight because mass does not depend on gravity. In a chemistry laboratory, an electronic balance is used to measure the mass of substance in grams. Temperature. Temperature tells us how hot something is and how cold it is outside, and it helps us determine whether we have a fever. In the metric system, temperature is measured in degrees Celsius. On the Celsius temperature scale, water freezes at 0 and boils at 100 degrees Celsius. While on the Fahrenheit scale, water freezes at 32 Fahrenheit and boils at 212 Fahrenheit. In the SI system, temperature is measured using the Kelvin temperature scale, which is the lowest temperature is 0 Kelvin. A unit on the Kelvin scale is called a Kelvin and not written with a degree sign. Time. The SI unit of time is the second. However, we also measure time in units such as years, hours, days, hours, and minutes. The standard device now used to determine a second is an atomic clock. Some useful relationships between different units for time follow.